With spanning tree protocol and rapid spanning tree protocol, you had the ability to manipulate the cost of an interface. And by doing so, you could influence the spanning tree topology. Because if you remember, the root ports and the designated ports are going to use cost as the first value that they look at when identifying the quickest path back to the root bridge. With spanning tree protocol and rapid spanning tree protocol, we were able to modify the cost on a VLAN by VLAN basis, but with multiple spanning tree protocol, we will be doing it on an instance by instance basis. The configuration is still done in interface configuration mode, and you will use the spanning tree MST command, specifying the MST instance, and then cost to adjust the particular cost. But I want you to notice something here. The cost values are significantly different than we are dealing with spanning tree protocol and rapid spanning tree protocol. In those cases, by default, the IEEE standard specified a cost of 100 for an Ethernet port, 19 for a fast Ethernet port, 4 for a gigabit Ethernet port, and 2 for a 10 gig port. But when we're dealing with multiple spanning tree protocol, the cost values are going to be 2 million for a 10 meg link, so Ethernet. For fast Ethernet, which is a 100 meg link, we're going to be dealing with 200,000. And then it's going to be 20,000 for a 1 gig interface, and then 2,000. It will be the value for our 10 gig interfaces. Why? You have more granular control over the cost now, especially when we're moving into ports on switches that have higher bandwidths associated with them. With the original implementation of IEEE for spanning tree protocol and rapid spanning tree protocol, we're at 2 and 4. We don't have a whole lot of granular control now over the costs when we're getting the higher speed links. So let's examine how we can change this between DSW1 and DSW2. On DSW2, if we examine the output of show spanning tree for MST1, we'll see here that the root port to get back to the root bridge is gigabit 1/0/5. And in this case, it has a cost right now of 20,000. If we look at gigabit 1/0/6, it's in the blocking state. It's the alternate port, also with a cost of 20,000. So let's modify the cost of gigabit 1/0/6 so it becomes the root port. We'll go into interface configuration mode, interface gigabit Ethernet 1/0/6, and we will type in spanning tree MST1, and we want to manipulate the cost in this case. So we'll specify a value that is less than 20,000. So let's try this, 19,999. Will that be enough to transition the interface? Let's check that out. Show spanning tree MST1, and we can see now that gigabit 1/0/6 is the root port because it has the lower cost, and gigabit 1/0/5 has become the alternate port in the blocking state.